In the 20th century alone, it claimed 150 to 300 million lives. In 1967, it was killing more Vietnamese soldiers than American bullets. Chloroquine had failed, quinine had failed, and the world's most powerful militaries stood powerless against a microscopic parasite. China's response was unexpected. Instead of turning to modern laboratories, they opened a 1,600-year-old medical text written by a physician named Ge Hong, containing instructions for a plant that kills malaria parasites in 24 hours. The first trials showed a 100% kill rate with 0 parasites remaining in the blood, producing a compound so effective it would win the Nobel Prize in 2015. The World Health Organization now discourages using the plant, pressuring companies to stop producing it in whole plant form, not because it doesn't work, but because it works outside their system. A $5 packet of seeds versus a $200 prescription, self-sufficiency versus supply chain dependence. A plant that cannot be patented versus a pharmaceutical market projected to reach $677 million by 2030. This is the story of sweet wormwood, the plant that cured malaria for 1,600 years, and why the institutions that profit from the cure don't want it growing in gardens. In 340 AD, during China's Eastern Jin dynasty, a scholar named Ge Hong compiled an emergency medical handbook called Zhou Hou Bei Jifang, or Emergency Prescriptions Kept Up One Sleeve, a survival guide for times when no doctor was available. Among hundreds of remedies, one entry stood out for its treatment of intermittent fevers, what we now call malaria. Take a handful of Qing Hao, soak in 2 liters of water, wring out the juice, drink it all. The instructions seemed simple, but contained a detail that would puzzle physicians for 16 centuries. Ge Hong never specified boiling the mixture. Every other herbal preparation in ancient Chinese medicine required boiling, decoctions, hot infusions, heat extraction. But for Qing Hao, which is sweet wormwood or Artemisia annua, Ge Hong specified cold water. For 16 centuries, that detail was copied from text to text, dynasty to dynasty. Physicians used it, it worked, but no one understood why the cold water mattered until 1971, when that single instruction became the key to saving millions of lives. By 1596, Li Shizhen, the most celebrated physician of the Ming dynasty, included Qing Hao in his compendium of Materia Medica, recommending tea made from it specifically for malaria symptoms. The plant became foundational in traditional Chinese medicine. The plant itself is unremarkable, an annual herb between 30 and 200 centimeters tall with feathery leaves and tiny yellow flowers. It grows wild across Asia, requires no care, and thrives in poor soil. By any agricultural standard, it's a weed, but inside those leaves exists a weapon against one of humanity's oldest killers. During the 1967 Vietnam War, malaria was decimating armies on both sides. In China alone, 30 million cases occurred annually with 300,000 deaths. North Vietnam's troops were dying faster from fever than from combat. The standard drugs had failed, chloroquine-resistant parasites were spreading, quinine barely worked, and Plasmodium falciparum, the deadliest malaria parasite, was winning. On May 23, 1967, the Chinese government held an emergency meeting in Beijing and launched Project 523, named for the date, a secret military operation with one mission: find a cure before malaria destroys the army. They screened 240,000 chemical compounds without success. In January 1969, they brought in Tu Youyou, a 39-year-old pharmaceutical chemist at the China Academy of Traditional Chinese Medicine. Her assignment was to review ancient medical texts and find what modern science had missed. She and her team investigated 2,000 traditional Chinese recipes, compiled 640 with potential anti-malarial properties, and tested 380 herbal extracts from 200 different plants on mice infected with Rodent malaria. Most produced inconsistent results or weak effects. One plant kept appearing in the ancient texts. Artemisia annua, sweet wormwood. They extracted it using standard scientific methods with boiling water and ethanol, but the results were frustrating. Sometimes it worked, sometimes it didn't. The compound seemed unstable. Tu was perplexed because the ancient physicians were clear that this plant cures malaria. She returned to Gehong's text from 340 AD and found the answer: cold water, not hot, never boiled. On October 4, 1971, Tu changed the extraction method. Instead of boiling water at 100 degrees Celsius, she used ether at 35 degrees with no heat degradation. The result was 100% effectiveness against malaria in mice and monkeys, but no one knew if it was safe for humans. Tu volunteered to be the first test subject, later explaining that, as head of the research group, she had the responsibility. She and 2 colleagues took the extract themselves, survived with no adverse effects, and clinical trials followed. All 21 malaria patients in the first study recovered completely, with parasites vanishing from their blood within hours. They isolated the active compound in 1972, a crystalline substance with the molecular formula C15H22O5 that they named Qinghaosu, meaning the essential element from Qinghao. The West knows it as Artemisinin. Artemisinin's molecular structure contains an endoperoxide bridge, a 1,2,4 trioxane ring with 3 oxygen atoms. This structure is rare in nature, chemically unstable, and highly reactive. Malaria parasites survive by consuming hemoglobin in red blood cells, a process that releases massive amounts of iron. When artemisinin enters the parasite and encounters that iron, the endoperoxide bridge breaks apart, generating free radicals, reactive oxygen species that shred proteins, puncture membranes, and destroy DNA. The compound functions as a chemical bomb that detonates only inside the parasite, killing it within hours, faster than any anti-malarial drug in history. By the 1980s, artemisinin had spread through China and Southeast Asia. Malaria cases in China dropped from 24 million in the early 1970s to tens of thousands by the late 1990s. In 1999, Novartis released artemether-lumefantrine, the first artemisinin-based combination therapy. The WHO recommended these combination therapies as first-line treatment for malaria in 2005. Between 2000 and 2020, artemisinin-based drugs saved an estimated 10.6 million lives, reducing malaria mortality by more than 20% overall and more than 30% in children, with over 100,000 lives saved annually in Africa alone. On October 5, 2015, Tu Youyou, then 84 years old, received the Nobel Prize in Physiology or Medicine, becoming the first mainland Chinese scientist to win a Nobel in a scientific category. She accomplished this without a doctorate, without training abroad, using only ancient texts and persistence. The Lasker Foundation called artemisinin arguably the most important pharmaceutical intervention in the last half-century. In 2019, after what they described as an extensive review, the WHO announced, WHO does not support the promotion or use of Artemisia plant material in any form for the prevention or treatment of malaria. Their stated reasoning included concerns about standardization, dosage variability, quality control, and potential for drug resistance. The position sounds reasonable until examined against the financial landscape. The global artemisinin pharmaceutical market was valued at $75 to $96 million in 2024, projected to reach $225 to $677 million by 2030. The artemisinin-based combination therapy market stood at $362 million in 2024, projected to reach $529 million by 2030. Major pharmaceutical companies like Sanofi have invested heavily in producing semi-synthetic artemisinin using genetically engineered yeast, a process that centralizes production, eliminates small farmers, and ensures artemisinin remains under corporate control. A packet of Artemisia annua seeds costs $5 online. The plant thrives in poor soil, requires minimal water, and produces multiple harvests per year. One backyard garden could supply anti-malarial tea for months. If people in malaria endemic regions simply grew Artemisia in their gardens and made tea, they would eliminate the need to purchase expensive pills from Novartis or Sanofi, making the entire supply chain unnecessary. From genetically modified yeast production through pharmaceutical manufacturing to distribution networks. The WHO's position protects that infrastructure and those profit margins. Since the 1990s, researchers have discovered that artemisinin targets cancer cells through the same iron-based mechanism. Malaria parasites hoard iron, but cancer cells require 5 to 15 times more iron than normal cells to sustain rapid growth and division, making them susceptible to artemisinin's effects. Studies from 2001 to 2020 show that artemisinin and its derivatives induce apoptosis in leukemia cells, colon cancer cells, breast cancer cells, and lung cancer cells, while disrupting cancer cell cycles and inhibiting angiogenesis, the formation of new blood vessels that feed tumors. This research exists in peer-reviewed journals, yet artemisinin remains absent from mainstream cancer treatment protocols. Artemisia annua and its cousin Artemisia absinthium, or bitter wormwood, also kill intestinal parasites, including tapeworms, roundworms, and pinworms. A 2017 study found that Artemisia absinthium extract caused paralysis and death in Hymenelepis nana, a common human tapeworm, while research on livestock showed that dietary wormwood supplementation reduced parasitic worm burdens in sheep. In developing countries where anti-parasitic drugs like albendazole are expensive or unavailable, wormwood represents an accessible alternative. It grows readily, requires no pharmaceutical infrastructure, and has been used safely for millennia. Yet the WHO and major health organizations remain silent on wormwood's anti-parasitic properties beyond malaria, with emphasis staying entirely on pharmaceutical solutions. The suppression of plant-based medicines has historical precedent. Artemisia absinthium bitter wormwood is the primary ingredient in absinthe. In the late 19th century, absinthe was the drink of Europe, consumed by Van Gogh, Toulouse-Lautrec, Oscar Wilde, and Ernest Hemingway, who called it the Green Fairy. It was also blamed for madness, violence, and moral collapse. In 1905, a Swiss man named Jean Lanfray murdered his wife and 2 daughters in a drunken rage. The press focused on the 2 glasses of absinthe he had consumed before the killings, while ignoring that he had also drunk cognac, brandy, crème de menthe, wine, and beer. A chronic alcoholic who had been drinking since breakfast. Prohibitionists invented a condition called absinthism, claiming that wormwood caused psychosis through thujone, a compound they described as a dangerous neurotoxin. By 1915, absinthe was banned across Europe and the United States. The French wine industry, which viewed cheap absinthe as competition, actively lobbied for the ban. The prohibition held for a century. In the 1990s, scientists tested vintage bottles of pre-ban absinthe and measured thujone content at an average of 1.3 milligrams per liter, far below levels needed for psychoactive or toxic effects. The madness was a myth. The hallucinations were extreme alcohol intoxication combined with adulterated cheap brands that added toxic substances like antimony and methanol. Modern research confirms that thujone at absinthe concentrations poses no more risk than any high-proof spirit. The European Union lifted bans in 1998. The United States followed in 2007, demonstrating how easily fear, misinformation, and economic interests can destroy a plant's reputation through trade wars disguised as public health measures. Organizations like Doctors Without Borders have successfully implemented Artemisia-based treatment programs in sub-Saharan Africa, training local farmers to grow and process the plant according to standardized protocols. These initiatives demonstrate that quality control and efficacy can be achieved without pharmaceutical industry involvement. When communities grow their own medicine, they become self-sufficient rather than remaining customers, a transformation that threatens the profit model pharmaceutical companies depend on. Artemisia is not a miracle cure-all, and raw plant material does vary in artemisinin content based on growing conditions, raising legitimate questions about optimal dosing. The beneficiaries of continued ignorance about the plant are not people in malaria, endemic regions who lack pharmaceutical access, not cancer patients seeking affordable complementary therapies, and not communities wanting healthcare self-sufficiency. The beneficiaries are pharmaceutical companies protecting market share, regulatory agencies maintaining institutional control, and a medical industrial complex that profits from complexity and centralization rather than from accessible, affordable plant medicines. Artemisinin-based combination therapies are effective and life-saving for those with malaria. The issue is not the science. Artemisinin represents a genuine medical breakthrough. The issue is who controls access to it. This pattern predates artemisinin. Hemp was required by law in colonial America, the most widely grown crop of the 1700s. It produced stronger rope than synthetics, more fiber per acre than cotton, and required no pesticides. The Marijuana Tax Act of 1937 eliminated it, not because hemp failed, but because it competed with synthetic fiber and paper industries that couldn't patent a plant. Amaranth was banned by Spanish conquistadors in the Americas despite producing more protein than wheat and thriving in drought. Banned because the Aztecs considered it sacred and cultivated it. Without European control, indigenous and traditional plants that enable sovereignty face systematic erasure or control, not because they fail, but because they succeed without permission. The plant has been used safely for 1,600 years and validated by a Nobel Prize in 2015. It kills parasites faster than any drug on the market and shows potential against cancer cells and intestinal parasites. The authorities classify it as dangerous to grow in gardens, claiming that standardization is more important than access. Standardization functions as code for centralization, corporate control, and profit protection. A packet of seeds costs $5, while a pharmaceutical prescription costs hundreds. One represents growing data and generational knowledge transfer, the other represents lifelong dependence on unaffordable pills. In her 2015 Nobel acceptance speech, Tu Youyou described artemisinin as a gift from traditional Chinese medicine to the world, adding that this was not the only instance in which the wisdom of Chinese medicine has borne fruit. She acknowledged what modern medicine consistently downplays. Ancient plant wisdom, tested across millennia of human use, often contains profound therapeutic value. Bottles can be banned and tea can be discouraged, but weeds cannot be patented. The knowledge lives in Geihong's text from 340 AD, in Tu Youyou's extraction method from 1971, and in the gardens of those who refuse to wait for permission. In forgotten plots and wild patches, sweet wormwood waits for soil, rain, and the next fever that breaks in 24 hours.